Hi everyone, welcome back to the workshop, and it's part 2 of the E3632A Agilent DC power supply. And if you've missed part 1, I'll link it in down below, and straight on with part 2. Previously I did some little bit of detective work and troubleshooting without removing the actual board from the case. Well, I've gone ahead and done that now, and I'm going to probe in the back here. I'm going to go over all the DC voltages that power all the various sections of the board. I'd done most of that prior to filming part 1, making sure all the voltages were more or less intact, and they were, but there were some sections I didn't manage to test, but now that I've got the board out I can get on with that. So luckily on the back of the board the silk screen's got a few of the test points for the various voltages, which I do recognise from the schematics, so I'll just go around them and make sure they're all okay. So there's basically two sets of secondaries on the transformer, which provide isolated supply voltages to the different sections of the circuit, one along the top here and another one down the bottom there. First of all, go over the top section. I've got the negative of the multimeter hooked up to an appropriate ground point on one of the ICs on the board. So let's go around all the power supplies here. So over on here we've got a plus 15 volts there. It helps if I switch it on, doesn't it? Should beep in a second. Okay. I've also had to extend the secondaries on the transformer with some test leads, some spades, etc. onto the board in order for me to arrange the board like this. Otherwise it was just too short and it would just be a pain in the neck with that transformer hanging around. So managed to do that, so let's get on. So this should be plus 15, 14.6, a little bit out. Next to that's plus 17.4, that goes away off to the display board. That's positive 18.1, and the minus 17.4, that's minus 18.2. All of these are a little bit off, but I don't think so much that it should cause that much of a problem. Certainly not getting it to boot up anyway. Here's minus 5.1, that one's spot on. And minus 14.9, yeah, that's on the minus 15 volt rail, that's fine as well. What else have we got? So U11 up the top here, that's the main 5 volts for all the logic ICs, the CPU, etc. That's spot on 5 volts, 5.02 volts, that's perfect. And yes, I did the minus 5.1. And on the bottom side of the board here, as it sits with me, I've got U10, which is a 5 volt regulator, a 7805. That's powering the GPIB section. So I'll just check the input to that regulator there. 10 volts exactly. And the output should be 5 volts. Yep, 5.02 volts. So GPIB section's perfect. Before I get started, oops, forgot to extend out the fan because this cable's not long enough, so I've just made a little extension and I'll just plug that in there. There you go, and there. And one thing I want to do before I get started probing around this motherboard is I want to do the self-test, the extended self-test. Someone on the part 1 comments mentioned that if you hold down one of the keys on the display as you power up, you'll get an extended self-test. So let's try that. So hold down this key here, power on. I'm holding it down, I don't know if you're supposed to let go of it. All characters, segments are on the VFD, so I'll release it now. Still giving me a single beep, and I've got nothing else on the display. Yeah, it's exactly the same as before. Okay, no problem. Okay, so I've had power on for about 10 or 15 minutes, and the ICs, the microcontroller, the ASIC, the RAM and the ROM, they're all warm to touch. I mean, it's very slightly warm, but that's just indicative of power up and functionality, I think. So even the GPIB section at the back, they're all, the microcontroller there, all just slightly warm. So it's a good sign to me that we've got power and they're doing something. But let's get the scope down onto the main board and let's probe around that microcontroller and see what we can find. Also gone ahead and put a little heatsink on this 5V regulator here. It's getting a tad warm, not overly warm, but definitely hot. And I think that's probably because there's no fan blowing across it, even indirectly, because the whole thing's out of case. So a little heatsink there will just save any problems there. Okay, so the first thing I want to do is look at the microcontroller and see if it's doing anything. See if it's set up right, see if it's got a clock, see what the reset pin's doing, and have a look at some of the bus and see if it's active at all. So first things first, look at the clock. That's at pin 67, 61, 62, 63, 64, 65, 66, 67 there. And we've got a nice 12 meg clock. It's 15 nanoseconds per division. Yeah, 12 meg clock there, so that's fine. And pin 16's reset, so 10, 11, 12, 13, 14, 15, 16. So that is high. That's correct. It's not normally 10, 11, 12, 13, 14, 15, 16. So it was sitting high. So I'll turn off power and then power it up again now. So what the service manual says is it will hold the reset low until such time the 5V rail is stable, and then it will let the microcontroller run, and that appears to be what's happening there. So I'll do that again. Yeah, it's going high almost immediately after power up, so there's not much delay in the reset circuit, that's for sure. And that could be okay. So the next things I'm going to look at is the read and write pins in the microcontroller. And let's see, they should both be active because there's external RAM and ROM. So first of all, pin 61 is the read pin. Well, that's handy, it's right in the corner. So that's the read pin there. Well, that's definitely active. Yeah. And the write pins in pin 40, so 43, 42, 41, 40. Yep, write pin's active as well, as it writes to RAM. And there's more reads than writes, that's normally the case as well, so that's good. Okay, so what I'm going to do is go right along the address bus on the microcontroller, which starts at pin 60, I believe. Handy enough, that's there. As you can see, that's active. Definitely doing something there. And the next pin along, it's going to go right along them. Make sure there's none that look like they're dead short or anything. And you can see it's changing there, so the address lines are active. It's not like they're fixed in one state, which would definitely indicate a problem. Some of them will be more active than others. I'll keep going. It's right along. There's 2 ports, I think, for the address bus. Right along one side of this IC, basically, bar one pin. Uses 2 ports of the microcontroller for that. And that one's a little bit different. As you can see, it's active. There's quite a lot of overshoot. The scope probe is compensated. It's just the fact that it's high frequency. The fact that there's some kind of repeating pattern on the address bus might be okay, but it could be that the microcontroller is not actually starting up properly and it's rebooting and rebooting and rebooting, and that could be down to a problem with the microcontroller itself or the RAM, the ROM. There's quite a lot that can cause that. Not too repetitive, so I'm not sure at the moment. My mistake actually, that was half the address bus and all of the data bus that I went down there. Okay, I think I've done enough probing in and around the board. I think it's time to take an IC off and change it out and see what happens. So, I was probing around the microcontroller, and it looks like the address bus and data bus are working or doing something anyway, but that doesn't mean that it's actually reading code properly and cycling through the various the firmware and doing what it needs to do for the board. It could be crashed, it could be doing anything, so it could be going in a loop for all I know. So I think what I'll do is, between the ASIC, the microcontroller, the ROM and the RAM, I'm going to replace the weakest link in that package of 4, and that's the RAM. So I've gone ahead and purchased what I think is probably a compatible RAM. I couldn't get the exact one that's on the board. They don't make that one anymore, and I couldn't pick one up. So it's quite a standard pinout, and I managed to find a couple. So on from RS. So let's remove that one and put one of the new ones on and see what happens. So first thing I'm going to do, I'm going to use hot air to remove it, but these capacitors here, especially this one here, it's a little bit too close to the IC for me to use the hot air, so I'm actually going to put a little bit of metal or something between the IC and the capacitor just to keep the heat away so that I don't melt the bottom of it. Okay, that's the chip out. So now I'll just use some wick and clean up the pads. Not so easy to get in about here, but take it real easy with the pads, because it's all too easy just to drag the soldering iron and the wick across them and rip the pads off, so I don't want to be doing that. Should really be doing it in line with the pads, but it's not so easy to get in around here, to get in about here, so I have to do it this way. Okay, that's the pads all cleaned up, ready for the new chip. I've used some IPA and a little bit of cloth and just cleaned up around about the area again. Got rid of all the flux that I'd added to help spread the heat, and it's ready for the new chip now. But before I do that, I'll put on my magnifying glasses and just take a quick inspection along the pads, especially underneath the IC, just to make sure there's no broken tracks or anything like that, which might have been responsible for the problem in the first place. You never know. Alright, there's the chip ready to go on, and so the process for this is just to solder, put a little bit of solder on one of the pads. So I'm just going for pin 1 here. Really awkward to get to, actually. This heat sink's in the way, maybe I should have removed it, but we'll try without it. There we go. That's pin 1 ready to go on. Get it the right way round. Yep. That's it in position. pin 1 soldered up, and all the other pads and pins are landed correctly. So I'll go away now and solder up all the rest of the pins and come back, and we should be ready for a power up. Let's have a look at the reset line on the ASIC, and that is pin 13. Luckily on this board they've annotated all 4 corners. It's really great to get to the pins. Lesson learned there for PCB layout. 10, 11, 12, 13. There we go. On the scope, that is not good. That is not what a reset should be looking like. I'll just double check that in the schematic. 10, 11, 12, 13. And that is paralleled up with the reset line on the microcontroller, which was pin 16, which I did measure before. So let's go back to pin 16 again. 10, 11, 12, 13, 14, 15, 16. Ah, something's changed. Let me reset the board. That's the power off and power on. I did measure that before, and that was working, or certainly wasn't a sawtooth like that. So back to the schematic, and here's a problem. Power on reset. This is what goes to the reset pin on the microcontroller, and this is the regulator IC, the 5V regulator IC. It's basically got your input there, your 5V output there, but it's also got some monitoring functions. It's got a reset and a delay pin. And basically what you can do is you can have the regulator monitor the 5V supply, and if it goes out of spec, especially during power up as the voltage rises, as the power gets switched on, it toggles a digital output when the 5V is stable, and that's what drives the reset pin directly on the microcontroller. And the idea behind that is if there's a brownout, or if the regulator's faulty, or something loads down the 5V rail, any number of things that can cause the 5V to be out of spec, then it will reset the microcontroller. So if you look closely at the regulator IC, LM2925T on the schematic, it's a different number that's actually fitted to the board. It's a CS8122 that's on my board, but I've got the data sheets for both of them, and they're absolutely identical, same pin out and everything. However, if you look at here, you've got pin 4 delay, pin 5 reset. That is back to front. On the delay pin, you set a capacitor value here for the amount of delay that you want when there is a brownout, or especially during power up. And the reset pin is the pin that goes away off to your reset pin on your microcontroller. So I initially thought, okay, the schematics just got it back to front. No, the board is wired up this way. So the question is, why is it working? Well, that is a good question. And I think there's a design error on the board and on the schematic that just by pure luck, having the delay pin going away off to the microcontroller and somehow tying the reset pin down to ground with a capacitor is somehow allowing this reset to toggle in the right direction immediately on power up. And if you look at the schematic for the other variant of this power supply, the E3632A, this is the 32A, look at the schematic there, they've got it correct. And just look at the board, this is pin 5 at this far end here. There's 2 pins underneath, it's 1, 2, 3, 4, 5, so that's pin 5 there, and you can see there you've got C22 capacitor just going down to pin 3, which is ground. So what am I going to do about it? Well, I did actually rewire the regulator correctly. I swapped the pins over, I swapped pin 4 and 5 over, And basically the board still operates in the way it always has been. Whether there's any more noticeable delay on power up, I haven't actually measured it yet, because it's quite quick with a 0.1 microfarad capacitor. It is quite quick. But probably what I will do is I will rewire it permanently if and when I can get the board fully up and running. Next, I've hit upon a small problem. Whilst I was probing around and just looking at the reset circuit, having a look at the data sheet, seeing what I could do, the microcontroller started getting hot. So I've actually desoldered it already. I've purchased a new one, and I'm going to fit the new one in its place. Don't know why it started getting hot. I think perhaps, well, I'm hoping actually, that the microcontroller's always been at fault, and hence why I've always needed to put a little bit of a heatsink on the 5-volt regulator, because it was just getting just that little bit too warm / hot. So I went ahead and desoldered the PLCC package, and I'm going to fit a new one. However, I have got a couple of sockets to try. I don't really want to take the new microcontroller and stick it right down on the board and solder it up in case I have to chop and change it again. So I have got a socket that I'm hoping to solder that into place, and then the new microcontroller will just snap into place. The particular one that's used on this power supply, it's ROMless, and that's why there's an EEPROM over here to store the program. There's nothing in here, so great stuff. I can just put the new one in. Hopefully that'll get me up and running. And in order to get it soldered in place, I'm going to use the heat gun again, the same as I did to remove the packages in the first place. So I went ahead and laser cut myself a small 68-pin PLCC stencil that I can just put into place and paste up the board so that I'm guaranteed, or almost guaranteed, no shorts when I reflow the microcontroller in place. So that'll be in the next video, hopefully coming very, very soon. Thanks for watching.